In this video, I will work on an example with central limit theorem for mean. Let me read the question first. The SAT math scores in a certain country are normally distributed with an average of 620 and a standard deviation of 50. Given the scenario, we are supposed to find these different probabilities. Let's look at the very first problem. Here, we are supposed to find the probability that a student has a score higher than 650. Let's make the graph for the given scenario. We are given a bell curve here. So we know the mean is right here in middle, which is 620. And here we are supposed to find the probability that a student has a score higher than 650. If 620 is here, then let's say our 650 is here. And we are supposed to find this area to the right. Let me show you how to find this area in a calculator. For that, each second distribution will be using normal CDF. So use this arrow key to get down there, then select that, hit enter. Let me clear what I have here. Here we will need lower value, upper value, mean, and standard deviation. So let's look at the diagram here. Let's look at the graph here. So from graph, we know our lower value is 650, which is this point here. So let's put that there. And upper value here will be really large positive numbers. So let me just type 10,000. And our mean is 620. Then our standard deviation is 50. Now hit enter, then enter. So we have this number here. So basically that's the area to the right here, this area. Okay, so let me put that down here. So that means this probability is 0.2743. Let me show you how to find this probability using formula. So for that, we'll be using this formula, which is z equals to x minus mu over standard deviation. Here, our x is 650, so let's put that there, and mean is 620, and our standard deviation is 50. Doing this math, we get z equals to 0.6. Now let's look at the table to find the area for z-score of 0.6. We'll be looking at here 0.6, this row, 0.6 row, and 0.00 column, so this column. So basically the area here is 0.7257, this number. Remember, that's the area to the left. This here, that is, this area is 0.7257. Actually, we are interested in the area to the right. That's what we need to find. So all we need to do is subtract this number from 1. So we get 1 minus 0.7257. We get 0.2743, which is this area here. Now, let me show you how to find this probability using Excel. So for that, type in equals, then type in norm.gist, then put your parentheses. Our x here is 650. Our mean is 620. Our standard deviation is 50. Since we are trying to find cumulative area up to 650, we will just type true, or you can simply type 1. Then close your parentheses, then hit enter. Excel gives us area to the left, which is this area here, and we need area to the right. So now all we need to do is subtract this number here from 1. So for that, you can type in equals 1 minus, then go up here and select that cell, then hit enter. Okay, so we got this number here, and this is exactly what we got using formula and also using calculator. So let's look at another problem. Now, here in this problem, we are talking about average of samples. And in such case, we need to first find a standard deviation for sampling mean using the formula given by Central Limit Theorem. That is population standard deviation over square root of sample size. This will be the standard deviation that we'll be using in our calculations, so which is equals to 50 over square root of 31, which is equals to 8.98. Now let's draw a diagram for the given situation here. We know mean is in middle, which is 620. We are trying to find the probability that a sample of 31 students has average score higher than 650. So let's say our 650 is right here. So now we have to find this area here. Now we can use calculator to find this area here. For that, let me pull up my calculator up on this screen. Now hit second distribution. Then we'll be using normal CDF. Then hit enter. Let me clear what I have over here. So we will need lower value, upper value, mean, and standard deviation. Now let's look at the graph for lower value and upper value. So looking at this graph, we know our lower value is 650, which is this point here. So let's put that there, 650, and our upper value will be large positive number. So that means I will just type 10,000 here. Now our mean is 620, and for standard deviation, we'll be using this standard deviation, this one, 8.98. So let me type that down there, 8.98, then hit enter, then hit enter. So we got this number here. So basically, this is the area over here, which is, let me write that down here. So this area here is 0.0004. Now let me show you how to find this area here using formula. So for that, we can just use this formula here, which is z equals to x minus mu over a standard deviation. So our x is 650, our mean is 620, and our standard deviation is, we'll be using this number, which is 8.98. This comes out to be 3.34. Now let me pull up the table up on the screen, and let's find the area for the z-score of 3.34. So which is, now we'll be looking at this row, which is 3.3, and this column, 0.04 column. So basically we'll be looking at row of 3.3 and column of 0.04. So the area will be this number, 0.9996. So that area is this one over here on the area to the left. So basically this one, 0.9996. Now we need, since we need the area to the right, this area here, all we need to do is subtract this number from 1. So let's do that. 1 minus 0.9996, which is equal to 0.0004. And this is exactly what we got using calculator also. Now let me show you how to find this area here using Excel. Type in equals, then type in norm.dist, then put your parentheses. Our x here is 650. Our mean is 620. Our standard deviation is 8.98. Since we are trying to find cumulative area up to 650, we'll be typing true, or you can just type 1. Then close your parentheses, then hit enter. This number here, this is the area to the left, and we need area to the right. So to find the area to the right, all we need to do is subtract this number here from 1. So let's do that. Equals to 1 minus this number here, then hit enter. So we got this number here, and which is the area to the right, and this is exactly what we got using calculator and also using formula. Let's look at another problem. Here we are supposed to find the probability that a student has a score between 600 and 650. Let's draw a diagram for the given situation. We know our mean is right here in middle, which is 620. And if 620 is here, our 600 is here. This is 600. This is 600. And our 650 is here. And we are supposed to find this area in middle. This area here. For that, let me show you how to find this area in middle using calculator. So let me pull up my calculator on the screen. Now go to second distribution. Then we'll be using normal CDF. Hit enter. So let me clear what I have here. Now we need lower value, upper value, mean, and standard deviation. So now let's look at the graph for the lower value and upper value. So looking at the graph, we know our lower value is 600, our upper value is 650, and mean is 620, and standard deviation is 50. Now let's hit enter and hit enter. So we have this number here, and this is the area in between 600 and 650. So let me write that down here. So basically this is 0.3812. So basically the probability that a student has a score between 600 and 650 is 0.3812. Now let me show you how to find this area in between using formula. So for that we can use this formula here, z equals to x minus mu over standard deviation. Here we will need to find z score for 600 and 650. Let's try to find z score for 600. So our x is 600. Our mean is 620, and our standard deviation is 50. When we do this math, we get negative 0.4. Now, we need to look up in the table to find the area for negative 0.4 z-score. So let's find negative 0.4 in here. So we'll be looking at the row of negative 0.4 and the column of 0.00. So basically this row here and this column. So the area to the left of 600 is 0.3446. So let me write that down here. So area to the left of 600 is 0.3446. Now let's find area to the left of 650. For that, our z-score is 650 minus 620 over 50. That equals to 0.6. When we do this math, we get 0.6. Now, let me pull up the table on the screen so that we can find the area to the left of 650. So, we'll be looking at the row of 0.6 and the column of 0.00. So, basically this number here, which is 0.7257. So this area to the left of 650 is 0.7257. 0.7257. Now, to find the area in between, all we need to do is subtract this number, that is 0.3446, from 0.7257, which is 0.381. So, which is this number here. Let me write that down here. So, 0.7257 minus 0.3446 equals to 0.381. 0.381. And this is exactly what we got using calculator also. Now, let me show you how to find this area using Excel. Now, let's try to find area to the left of 600. For that, type in equals, then type in NORM dot DIST, then put parentheses. Our X here is 600, our mean is 620, our standard deviation is 50, and since we are trying to find cumulative area up to 600, we'll be typing true, or you can simply type 1. Then hit enter. So we got this number, which is area to the left of 600. Now let's find area to the left of 650. So for that, type in equals, then type in NORM dot DIST, then put parentheses. Our X here is 650, then mean is 620, then standard deviation is 50. And again, here we are trying to find cumulative area up to 650. So we will be typing true, or you can simply type 1, then hit enter. So this number here this is the area to the left of 650, and we need area in between 600 and 650. All we need to do is subtract this number from this number here. Let's do that. So type in equals, then select that, then type subtract sign there, then select that, then hit enter. So you get this number here, and which is exactly what we got using calculator and also using formula. Now let's work at the very last problem. In this problem, we are talking about average of samples. In such case, we need to first find standard deviation for sampling mean using the formula given by Central Limit Theorem. That is population standard deviation over square root of sample size. This will be the standard deviations that we'll use in our calculations, which is equal to 50 over square root of 31. And this is equal to 8.9803. Now, let's draw a diagram for the given situation, and we are given a bell graph here. We know mean, which is 620, lies in middle, so this is 620. And here we are supposed to find the area between these 2 points, 600 and 625. So let me show you this area. So basically, we are supposed to find this area. Now, we can use calculator to find the area in between 600 and 625. So let me pull my calculator up on the screen. Now, you need to go to second distribution, then we'll be using normal CDF, so which is number 2. Select that, hit enter. Let me clear what I have on the screen. So basically we need lower value, upper value, mean, and standard deviation. So let's look at this diagram here to find out our lower value and our upper value. So looking at this diagram, we know our lower value is 600. So let's put that there. Our upper value is 625. Our mean is 620. And our standard deviation, we'll be using this standard deviation, which is 8.9803. Now hit enter and hit enter. So we got this number here, and basically that's the area between 600 and 625. So let me put that down. So basically this area here is 0.6981. And the probability that a sample of 31 students has average score between 600 and 625 is 0.6981. Now, let me show you how to find this area here by using formula. So for that, our formula is z equals to x minus mu over standard deviation. So using this formula here, we need to find the z-score for 600 and 625. Let's do that. Let's find the z-score for 600 first. So x is 600, our mean is 620, and our standard deviation is 8.9803. So when we do this math, we get negative 2.23. Now we need to look up in the table to find the area for this z-score. So let me pull up my table on the screen. So now we'll be looking at the row of negative 2.2, which is this row, and we'll be looking at this column here, this column. So basically this number here, which is 0.0129, is the area to the left of 600. So let me put that down here. So this area is 0.0129. Now let's find the z-score for 625. So x is 625, our mean is 620, and the standard deviation is 50. So when we do this math, we get 0.56. Now to find the area to the left of 625, we need to look up in the table for the z-score of 0.56. So let me pull up my table on the screen. Then we'll be looking at this row, which is 0.5, and we'll be looking at the column of 0.06, which is this column. So here, 0.7123, basically this number here, which is 0.7123, is the area to the left of 625. So let me put that down here. Area to the left of 625 is 0.7123. Now to find this area in between, all we need to do is subtract this number here from this number. And we get 0.6991, which is basically the same as what we got using calculator. Now let me show you how to find this area here using Excel. So let me pull up my Excel on the screen. To find first we need to find the area to the left of 600. So for that, type in equals, then type in norm.dist, then put parentheses. Our x here is 600. Our mean is 620. Our standard deviation is 8.9803, And since we are trying to find cumulative area up to 600, we can either type true or simply type 1, then close parenthesis, then hit enter. So this number here, this is the area to the left of 600. Now let's find area to the left of 625. For that, type in equals, then type in norm.dist, then put parentheses. Our x is 625, our mean is 620, our standard deviation is 8.9803, and we can just type true since we are trying to find cumulative area up to 625 and close parenthesis, then hit enter. So this number here is the area to the left of 625. Since we are trying to find area in between, all we need to do is subtract this number from this number. So let's do that. Type in equal, select this, then put subtract sign there, then go here and select that, then hit enter. So we got this number here, which is the area in between 600 and 625, and this is exactly what we got using calculator and also formula. Finally, we are done, and I have listed all the probabilities here. Thank you for watching. We hope this video was helpful. Please like and subscribe our channel. We will be bringing more and more videos on variety of topics.